Cisplatin is one of the most effective chemotherapeutic agents that is extensively used for the treatment of ovarian, testicular, bladder, lung, and breast carcinomas. However, nephrotoxicity is the major adverse effect representing a dose-limiting factor in cisplatin therapy. There is a substantial evidence supporting the role of reactive oxygen species and lipid peroxidation in renal damage that develops in response to cisplatin. Telmisartan is an angiotensin II receptor antagonist used for treatment of hypertension. Recently, it was demonstrated that telmisartan had a significant antioxidant activity and protected against oxidative tissue injury in different experimental models. The present study was performed to evaluate the protective effect of telmisartan against cisplatin-induced nephrotoxicity. The rats were randomly assigned to 3 groups. The first group received a single intraperitoneal dose of normal saline and served as a control group. Nephrotoxicity was induced in rats of the second and third groups by a single intraperitoneal injection of cisplatin 20 mg per kg. The second and third group animals received daily intraperitoneal injection of 1% aqueous solution of telmisartan 10 mg per kg respectively for 6 consecutive days starting 3 days before cisplatin administration. 72 hours following cisplatin administration, the animals were sacrificed and blood samples were collected and centrifuged for 10 minutes at 5,000 rpm. The obtained sera were stored at -20 Celsius till the levels of blood urea nitrogen and serum creatinine were determined using colorimetric assay kits according to the manufacturer's instructions. Following blood sampling, the kidneys was removed, washed in cold saline kept at -80 Celsius, and were subsequently homogenized in cold potassium phosphate buffer. The homogenates were centrifuged at 5,000 rpm for 10 minutes at 4 Celsius. The supernate was used for determination of oxidative stress biomarkers, malondialdehyde, reduced glutathione levels, and catalase activity, and nitric oxide level, as a pro-inflammatory mediator using colorimetric assay kits as indicated by the manufacturer. The left kidney obtained from each animal was fixed in 10% formalin solution, dehydrated in ascending grades of alcohol, and embedded in perforin. Sections at 4 micron thickness were taken, stained with hematoxylin and eosine solutions, and examined under light microscope. The cisplatin-induced elevations in blood urea nitrogen and serum creatinine levels were significantly reduced to the normal values by telmisartan treatment. Also, telmisartan significantly reduced the increased malondialdehyde and nitric oxide levels and restored the reduced glutathione level and catalase activity in renal tissue of cisplatin-treated animals. Those 3 figures show the photomicrographs of the kidney rat. The first photomicrograph is for the control group, which shows the normal renal architecture. The second photomicrograph is for the group that received cisplatin and shows renal tubular necrosis, interstitial edema, and intralemenar casts. While the third photomicrograph is for the group that is treated by telmisartan and shows remarkable improvement in histologic picture with absence of cisplatin-induced tubular necrosis, edema, and cast formation. The present study demonstrated that telmisartan provided a significant nephroprotective effect against cisplatin-induced acute renal damage. Therefore, telmisartan can be considered as a potential candidate to minimize cisplatin nephrotoxicity, which is a major and dose-limiting clinical problem.